All right, guys, I asked you in the first question if the point -2, 5 is a solution to that statement, that inequality. The section that we are starting today is us trying to solve this inequality for all of the x and y values that make it true. So if I ask you if this point is a solution to that, guys, when they give you an ordered pair, they are giving you a number as the what coordinate first, x, and a number as the what coordinate second. So they've given you a number that you can plug in for x and y, and all you have to do is figure out if it makes that statement true. So if I plug -2 in for x and 5 in for y, it's going to say -2 plus 5 has to be greater than -3. What is -2 plus 5? Is 3 greater than -3?
Yeah.
Oh, yeah. So that means that this point made that inequality true. So it means that this x and that y value are a solution to that statement. So the answer is yes. All right, then I asked you, is the point 4, -3 a solution to the exact same statement? So try it again. When you plug in 4 as x and you plug -3 in for y, does it make a true statement? Well, that's going to say 4. Then you have to add y, but what's plus -3 really going to be? -3. And then it has to be greater than -3. So you end up with this. Is 1 greater than -3? Yeah. So is he a solution to that inequality? Yeah. So now it's kind of like, well, wait a minute, Hardy. You mean to tell me somebody could say this is a solution, somebody else could say that's a solution, and they're both right? Yes. Because what I need you guys to understand is when you are working with inequalities, especially ones that are in 2 variables, guys, there are so many x and y values that are going to make this statement true. So many that you couldn't possibly sit here and try and list them all. Those are 2 x and y values that are solutions, but there are infinitely many more. And in situations where there are so many answers that we couldn't possibly list them all, the way we show the answer is on a graph. You're going to graph all of the x and y values that make this statement true, because you couldn't possibly sit here and list them all. And since this is a linear degree 1, no x squared, no x's to the third, this is a degree 1 inequality, we can graph it as a line. So we're going to graph these as lines, and then the lines are going to become boundary lines. And then we're going to have to shade on one side of the line or other to show where, yeah, you did this now, where you have to show where all of the x and y values land that will make this statement true, because these problems have infinitely many answers. So the only way to show all of them is on a graph. All right, so guys, look at your notes. And then if you have Delta Math, I do have it set up where each problem corresponds to a problem on Delta Math, so then I can make sure you are comfortable with what it's going to look like on your homework tonight. All right, here we go. Before we start solving, we are solving linear inequalities today. We are solving them by graphing. So I've given you a list of steps. Since these are linear inequalities, we're going to graph them as lines. So the first thing you want to do when you start solving them is you want to solve the inequality for y. Get y by itself so that you can think about it in y equals mx plus b form, so that you can identify a slope, you can identify a y-intercept, and you can create the line very, very quickly. That line then acts as a boundary between answers and non-answers, okay? All right, graph the line and then shade where the x's and y's are that make the statement true. Please remember inequality symbols. There are 4 inequality symbols. There are less than symbols, and then there are greater than symbols. So guys, you're used to seeing an inequality where it's only talking about one variable, x, in a 1 dimension, a horizontal number line, right? We would go, oh, what, 0's here, 5's there. This is saying that x can be any number less than 5. Was 5 himself an answer? No, right? So 5, he's your boundary number. You're going to go right up until 5, but you're not going to include him. Does anybody remember what kind of circle you used at 5 to show that he was not included as an answer? An open. Beautiful. So what happens is, when you graph the line and he becomes your boundary line, kind of like this number became our boundary number, sometimes the points on the line are going to be included as answers. Sometimes the points on the line are not going to be included as answers. It depends on the symbol. So if they say we only want the points that are less than or greater than the line, then that means the points on the line aren't answers. They're just the boundary. It's the equivalent of having an open circle. So to show that the points on the line aren't included, you have to use a dashed or a dotted line. I don't know if this rings a bell, but you're going to use a dashed line. I call it dashed, you might call it dotted, all right? So the dashed line gets used when it's not equal to, when you're not allowed to equal the points on the line. Then you have the less than or equal to and the greater than or equal to symbol. So now if the problem said this, and it said x could be any number less than or equal to 5, was 5 now an answer? Yeah, he was an answer, and he was the boundary cutoff number. So what kind of circle did you use to say, hey, we're going right to 5 and we're including 5? Using a closed circle. So now when you're going to graph a line and it uses one of those symbols, now it's saying that the points on the line can be equal to your answers. Now the points on the line are answers. So that would be the equivalent of like a closed dot. So you're going to use a normal solid line when you want to include the points on the line as answers. And again, this will probably make more sense when you start seeing it, but I like to put it in writing so you have it written down. And guys, I'm not lying. I've been teaching for 17 years. This step always gets me because you have been trained for years and years and years to connect your dots with a solid line. So it's really easy to forget about the damn dashed one. I do it all the time. So just pay attention to your symbol as to whether or not you're supposed to be using a dash or a solid line. All right, let's do it. Let's look at number 1. Let's just use my mouse right here. Yep. Ooh, fancy. All right, so our job is to graph the solution set. So all the x and y values that are going to make these statements true. All right, so look at number 1. We have to find all of the x and all of the y values that will make this a true statement. Well, the easiest way to do it is because these are linear inequalities, is graph a line and then shade where the answers are. So if we're going to graph a line, what variable do you need by itself? Y. Is it already done for us? Yeah. Gotta love that. Great. So guys, look at this. Picture it like it says y equals mx plus b. Who's your y-intercept? Put it on your graph, -5. Okay? Use your slope to make more points on this line. Who's our slope? -3/4, right? I like to give the negative to the top number and keep the bottom number positive. So rise over run. How do you rise -3? Down 3. And how do you run +4? Right 4. Beautiful. And you can keep doing it. Down 3, right 4. Down 3, right 4. Or I'm going to run out of graph. I'm going to go back, do the exact opposite of down 3, right 4, and I'm going to go up 3, and thank you, Brendan, left 4. All right, now guys, here's the annoying part. Because we are graphing this as a line, we're basically comparing the entire statement to y. We are saying that we need to show where all of the y values are less than the points on this line. So guys, if they want you to show the y values that are less than the points on the line, are you allowed to include the points on that line if y can only be less than that? So what kind of line should you connect your dots with to say this is my boundary line and none of the points on it are included? Dotted line. Okay, guys, a line has 2 sides. So you got a 50-50 shot here. You're either shading on this side of the line or you're shading on this side of the line. Those are your only options. You got to look at the clues though. It says they want the y values to be less than the line. Guys, your y-intercept literally cuts the y-axis in half. You now have the y values up here getting bigger and bigger and bigger on this side of the line. Then you have the y values on this side of your line getting smaller and smaller and smaller on this side. They want y to be less than that line. So if they want you to show where all the y values are less than the line, should you shade where the y is above or below your line? Below. So you shade below. Any ordered pair that falls underneath that line is a solution to that statement. I'm telling you right now, If you picked this point, or 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 this one, if you plug that X and Y in, they're going to make that statement true. Those are the solutions. All right, now if you're sitting here saying, I don't know, honey, that shade is gonna be a little iffy. Here's what I could advise you to do. That's probably the quickest and easiest thing. Pick a point that is extremely easy, that is clearly not on your line. Let me give you a suggestion. A really easy ordered pair that is not on my line is that guy right there. What ordered pair is that? I don't know if there's an easier X and Y value to work with. Is he where we shaded? No. That means he's not an answer, and that's okay. That means if he's not an answer, he's not going to make that statement true. These are the points that are going to make that statement true. So as long as you plug this in and he makes it untrue, you know you've picked the right side, because this is not where the answers are. If you plug him in and he makes it true, it's like, holy shit, he's an answer. Oh, sorry. Holy shoot, he's an answer. You should have shaded there then, but you didn't. So he shouldn't make it true. So guys, really quick. 0 less than -3/4 times 0 minus 5. 0 is less than, what's -3/4 times 0? 0 minus 5 is that true? Is 0 less than -5? No, and it shouldn't be true, because that's not where the answers are. And that's a really quick way to know if you've shaded on the correct side or not. All right? All right, Chris, if you got to go, you can know now. All right, let's do number 2. Oh, wait. No, wait. 1 second. All right, go to Delta Math. Looks like nobody has it out. That's wonderful. Great. All right, so I gave you the exact same problems on Delta Math so that you can see what the homework is going to look like. So on Delta Math, here's the line. We just graphed it. So I'm going to go down 5. I'm going to click on the dot. My line appears. Use your slope 1 time to click on your next dot. I'm going down 3 and right 4. Boom. Okay. The minute you graph a line, the minute you click on 2 dots, these options appear. What did we say we wanted? A solid or a dashed line? Because a solid line always appears first. We wanted a dashed. So all you have to do is click the change line button, and it'll toggle back and forth between a dashed line, and you're like, oh, no, I wanted a solid line. Then click it again, and it goes back to a solid. So hit the change line button until you see the correct kind of line. Now we got to put our shading. It feels like you should be able to click somewhere that you want shading. All you have to do to add the shading now is hit the change shade button. And the minute you hit the change shade button, it's going to throw shade here, or it's going to throw shade here on one side of the line. And you just keep clicking it until it's on the side of the line you want it. We said we wanted it below, on this side. So just hit the change shade button. Is that the side we wanted it on? Yes. Leave it. Don't hit it. If it wasn't, hit it again. And then you're like, oh, no, that wasn't. Okay. Then just keep hitting the change shade until you're happy. And you're done. And then you go down to your submit answer and get your green check. Super easy. I just like you guys seeing that before you have to do it on your own. Is it cool? Would you say the word cool? Because math is cool, Steven. All right. Here we go. Let's do number 2. Everybody do problem number 2. Is Y already by itself? Yeah. I love them, guys. So don't do it on Delta Math. Do it on here. Do it on your notes first.
Wait, just I thought it was
yeah, and they're the same 4 problems from your notes. I lined them up. All right, Chris, you're good. I wanted you to see the Delta Math. Now you've seen it.
do I need?
Do you have one or do you need one? I'm running out of markers here. All right, we graphed our y-intercept. Now we're using our slope, rise over run, up 2, right 5, down 2, and left 5. And then the clues. We are going to show this and compare our answers to y. We have to show where y is greater than or equal to that line. So did you use a solid or dashed line with this one? Solid. This is saying that y is allowed to be greater than the points on the line or equal to the points on the line. So now the points on the line, they are the boundary between your answers and non-answers, but they themselves are included with the answers. It can be greater than or equal to the points on the line. So nice and solid to show that. And like I said, guys, a line only has two sides. One of them's the right side. So we compare this to y. So they're asking y to be greater than that line. So you have y above up here getting bigger than your line, or you have y down here below your line getting smaller. So if they want y to be greater, we're going to shade where y is above. Greater is above and less than is below. So any ordered pair that falls above that line is a solution to that statement. And again, 0, 0 is not where we shaded. So yet again, 0, 0 is not an answer, but he's a really easy test point. So as long as you can plug 0, 0 in and he doesn't make it true, you know you've picked the right side, if you feel like you need to test something. All right? And then we'll show it on Delta Math. Because I have a nice mouse, why wouldn't I? All right, we're going to go up 3, up 2, right 5. I wanted a solid line. It's automatically solid. I'll hit that change shade button until it's on the side that I want, and then I'll submit my answer. Boom. All right, look at number 3. What's wrong with number 3? It's not in point slope form. It's not in mx plus b form. So again, our job is to find the x and y values that make this true, but the easiest way to do that is to compare it to y so I can graph it as a line. Let's do it. Guys, what are you doing first to get y by itself? Subtract x, right? We're ready for this? That leaves you with negative 5y's. Less than, I'm going to put my negative x first, and then my positive 20. What's the only thing you have to do to get y alone? Divide by who? Ooh, guys, you're about to divide both sides of an inequality by a negative number. What do you have to do? You got to flip that symbol. So the flipping symbol comes back here. All right? So we're going to divide by a negative. That means we flip. And truthfully, what number is in front of x that I'm actually dividing? Negative 1, right? Okay. All right, here we go. Y, symbol has to flip. Negative over a negative is positive. 1 over 5 doesn't divide, doesn't reduce, times x, and then minus 4 now, 20 divided by negative 5. All right, guys, graph it. Are you going to use a solid or dashed line? Ooh, dashed, right? It's only saying that it wants y to be greater than this line, but not equal to it, so dashed. Up 1 and right 5. We're going to go down 1 and left 5 using the slope in the other direction, right? My y-intercept and my slope. And like we said, we are asking us to show where the y values are greater than the points on this line. So the points on the line are a boundary between your answers and not answers. And since y can only be greater, we can't include them. So we're going to show that they're not included by using that dashed or dotted line. All right, now we shade. Guys, the y-intercept cuts your y-axis in half. We have this side where this y-axis is, and then we have this side where that y-axis is. We got y values getting bigger than our line on this side, and we got y values getting smaller than our line on this side. Where are we shading if we want y to be greater? Where y is above or below? Up. So any ordered pair up here. Any ordered pair above that line is a solution to this inequality. And now, guys, 0, 0 is where we shaded. So 0, 0 should make this true if you plug it in. If you wanted, I'm not saying you have to, if you wanted to test. All right, and then I'll go to Delta Math. We got negative 4 was our y-intercept. I went up 1 and right 5. I needed a dashed line, and my shading was above. And then I should be able to submit it and go. All right, you guys do the last one. Well, that last number 4. I got to talk about the horizontal and verticals. So do number 4, and you can check it because Delta Math will tell you if you're right or wrong. That is the last problem on Delta Math, which is number 4 in your notes. Number 5 and 6 are not on Delta Math. They're in your notes only. Does this feel better than what we've been doing? A lot better. All right, so if you want to graph this, you got to solve for y, so you can get your slope and y-intercept. What do you got? Where we at? Of course, of course. Do you have your graph or do you need one? All right, I'm going to try and catch up to you guys. We're going to get y by itself. You are dividing by a positive 5, so no reason to flip. What's up, Kayla? Want me to wait for somebody to come back? Okay. Y is less than or equal to, that does not divide or reduce, so we leave it. And then minus 1. Hopefully we're not having any trouble graphing. I have a y-intercept at -1. I have a slope of -2/5, so I will rise down 2, and I will run to the right 5. I will go up 2, and then left 5. Solid or dashed, if that's our symbol. Solid, right? We can be less than or equal to the points on the line. So now the points on the line are a boundary, and they're included as answers. All right, we got two sides. We got this side, and we got that side. We got y up here getting bigger than our line, and we got y down here getting smaller than our line. We want y to be less. Where are you shading, above or below? Any ordered pair that falls down here is an answer to that inequality. Go ahead, Derek.
You only flip when it's negative.
Only when the number in front of y is who you end up dividing by. So when the number in front of y is negative, you're going to have to divide by a negative and then flip that symbol. All right, guys, look at example 5 and 6. Listen, I love Delta Math. I can't always understand why there are certain topics he doesn't include in his question bank, but either way, the horizontal and vertical lines definitely seem to be the ones that give some of you the most run for your money. So I definitely want to keep showing you these. However, I couldn't find them on Delta Math. I went through, I feel like 50 questions. Next problem, next problem, next problem. It didn't have any horizontal or vertical lines. So at least let me do 2 with you to kind of keep it in our mind, but they're not on your homework. I couldn't find them to assign you for the inequalities at least. All right? All right, so guys, when we graph horizontal and vertical lines, first of all, when you graph a line, this is our baby. Y equals mx plus b. M and b always get replaced with numbers. So how many variables are in our equation every time? X and y, right? They represent the x and the y coordinates of the points on your line. The dead giveaway that you are looking at a horizontal or vertical line is how many variables are in their equations. Just 1. If there's only one variable, that is a horizontal or vertical line. So guys, if you're asked to find all of the answers to this inequality, how many variables are you looking at? It's just y, right? All you have to do is graph this and shade. You're finding all the y values that make it true. But guys, we're still living on a 2-dimensional space, an x and a y axis. So you still got to graph the line. So since y is the only variable, bells, whistles, sirens should be going off in your head. Oh, this is horizontal or vertical. All right? Get y by itself. It's who we normally solve for. Plus, he's the only one here. So you got to get him by himself. So let's add 2. -3y is greater than or equal to -15. What's the only thing you have left to do? By who? Ooh, you just divided both sides of an inequality by a -3. What do you have to do? Flip that symbol. Okay, so guys, do me a favor. First, you need to graph your line. So think of this as this line. Graph me the line y equals 5. Graph me the line where every single dot has a y coordinate of 5. So guys, where's y5? Right, left, up, down? Up 5. That point has a y coordinate of 5. Plot another point that has a y coordinate of 5. I'm going right there. Plot me another point that has a y coordinate of 5. Right there. Plot me another point that has a y coordinate of 5. Guys, what kind of line is formed when y is always 5? No. Horizontal. Is it solid or dashed if you are trying to show where all the y values are less than or equal to 5? Solid. Now 5 is included. He's our boundary, and we can be equal to him. So it's that line. Well, guys, again, a line has two sides. We got above, and we got below. This is where y is getting bigger, above our line. This is where y is getting smaller, below it. If they want y to be less, where are you shading? Above or below? Below. Any ordered pair that falls below this line is a solution to that inequality. All right, last one. How many variables do you see in that statement? 1. So it's a dead giveaway that this is horizontal or vertical. Who's the only variable it does have? And he's not even the one we usually get by itself. We solve for y. But guys, he's the only variable there. So solve it for x. It's the only choice we got. 2x is greater than 6. What's the only thing we have to do? Any reason to flip? No. Okay, so we have to show where all of the ordered pairs are that make this statement true. Well, guys, first, graph me this line. Graph me the line where x equals 3. So where is x3? Right, left, up, down? Right. Plot another point where x is 3. Boom. Do another one. Boom. What kind of line is being formed? Vertical. Now look it. We're trying to show where all of the x values are going to be that are greater than 3. Am I allowed to equal 3? No. So are these points on this vertical line included as answers? Solid or dashed? Dashed will show that they're a boundary, but they're not included. Now a vertical line is a little different, right? He doesn't have up or down. He's got right and he's got left. You are trying to shade where x is greater than 3. So we got x's out here to the right getting bigger than our line. And we got x's over here to the left getting smaller than our line. So if x has to be greater, are you shading on the right side or the left side? Right. Done. Any ordered pair over there makes this statement true. How do we feel? Good? Okay, here's the deal. You have a homework on Delta Math tonight that looks just like the problems we were doing in the beginning. The shade, change line, okay. That is due tomorrow night like normal at 11:45. It's Friday night though tomorrow, so I don't know if you want that. Tomorrow, I'm going to give you some problems in class to kind of work on this one more day. And then guys, after this section, there is one section in chapter 2 that we have the option of doing or not doing. I think I'm going to not do it. Terry like flung his head around. And I think I want to start reviewing for our chapter 2 tests. We only have 4 days of school next week. So I want to make sure I give you maybe 1 or 2 days to review, and then we need 1 day to test. On Wednesday next week, I don't see you guys, and I don't see my 7th period class because they're taking Algebra 2 teachers, Algebra 1 teachers, and Geometry teachers, and they're sending us to a half of a professional day. So you guys will definitely have a sub Wednesday. Guys, that means I have to test you on Thursday, and you guys have a terrible habit of saying, oh, look, it's the day before a break, I'll take that day off too. So I'm definitely afraid of it having to be on Thursday and you guys not coming, and now you have a test to pick up after 10 days off of school. So listen, the chapter 2 test has to happen. It's looking like it's going to have to be Thursday. I hate to give it when I'm not here on Wednesday. But that gives us Monday and Tuesday to review, and then it gives you guys Thursday to take it, because I'm sure Wednesday when I'm not here, you will find something to do. All right? All right, so that's kind of looking like how it plays out. Well, I'll let you know if anything changes. Before yesterday's quiz, you guys were killing chapter 2. So I hope that the chapter 2 test can be very, very good for you guys. Question, somebody had a hand up. Yes, no? What's up? Oh yeah, we got time, I think. We have 8 minutes. Technically 9 with these bells being a minute late. Do me a favor today. Stay in your seats. I can't take the standing at the door for 5 minutes. It's just eating away at me. If it was 10 seconds, I could take it. The whole 5 minutes, though, is too long. You did?
Yeah, same way.
Good done, Steven. Let's go, Cole.
Are you gonna post as an assignment?
Take post what?
Are you gonna post as an assignment? It doesn't matter.
The notes one or the homework? It's not posted.
What is that?
It should say 2.8 notes, and then there should be a homework 2.81 or number 1. Is it not there?
She's looking at on the classroom.
Oh, it's not posted on Google Classroom? What? I only posted period 2 today. Holy cow. Thank you, Bianca.
And he's gonna be one of the girls today.
Oh my God, I'm such a jerk. That's why I telling Pierre, I'm like, guys, what do you mean you don't see it on the note? I didn't post it. Oh. Shabaya, if you don't have any questions, you're good to go, sweetie.
Exactly.